So let's do a while. So while tab. Okay, and in here, we'll go ahead and leave it as a true. Go ahead and press enter. And then we need a variable. So we need a variable before the while loop. And let's just go ahead and create an int. Before the while, go ahead and start a new line. And let's do an int I equals 0. And then inside of the while loop, just do console write line, I++. Do you remember what the plus does after and before?
So after would be increment by 1, and before is decrement?
No, they both increment. The plus
Just
before and the
and
plus after both increment, but the plus after means that it's going to read whatever value is in there and then increment. The plus before, it says what it does, it increments it first and then reads it. Okay, so let's go ahead and run this and let's see what it does. Let's see how far it gets before it crashes. This has to crash somewhere.
Whoa, it's going.
How long does it go? This might take a little bit.
50,000, 60,000.
Let me see if I can find the this may take a little bit, but it'll give me some time to do a little bit of Google searching. C#, small int. Oh, maybe that's what I want. C#, tiny int. Here we go. No. C#, number types. It's still going, huh?
Yep.
That's going to go for a little while. Okay. Here we go. Okay. Go ahead and Control C to kill this. This is going to take too long. And let's go back to your program and switch that int, and let's switch it out for a byte or int. No. Yeah, let's switch it out for a byte. Yep. And call it I. That's fine.
Equals I?
No, just I. Instead of int I, this is going to be byte I.
Okay.
So we're just switching out the I type from an int to a byte. And what it is it's just the number of bits that it has. So there's an S byte or a byte, which is an 8-bit integer. In other words, remember the 4 bits that we had that you can flip on and off? Well, this one has 8 that you can flip on and off. So you have 0 all the way to 256 when you do powers of what is it? 2 to the what is it? N to the 2 or something like that? Is that how you would read it? Yeah. But here it should fail after 255. So let's try to run this and see what we get.
Oh.
Okay. No, cancel that. Okay, so a byte doesn't like it. How about, all right, let's do int. Let's do int 16. No, the int 16 is a type.
Wait, what do you mean?
Let's see. Oh, actually, it'll be called a short. Sorry, it'll be short I. Yeah, so a short will only give us 32,000 numbers. Let's see, try to run that. No? Okay, hit no. It doesn't like the short either, huh? Int is the only one that's going to be... I could have sworn. How about if you switch out the plus plus to a +1?
Run it.
No, it doesn't. There's an error in there. What hover over that I, see what it does. Oh, I know what's going on here.
Exception.
Go back to switch that short to a byte again. And then put I equals 0. There we go.
All right.
That we didn't assign it. It was a problem. We have to assign it before we use it. So go ahead. Now it should work.
Oh. It's just giving me ones.
I +1.
Oh, because we did the +1. That's why.
Oh, okay. Try to do the plus plus.
Oh, it's still going.
Yeah, you got to Control C.
Oh, it's repeating itself. Yeah, it's just repeating itself.
Oh, that's interesting. So it just goes back to 0, huh?
Yeah.
Well, that's a bunch of malarkey. I expected this to...
Oh, yeah, it's just, yeah.
Yeah, go ahead and kill this. I expected this to tell me like, hey, I reached the maximum number. But all it does is just go back into a loop. That's crazy. Okay. That's fine. We're gonna brute force this. Let's do a console write line, and we're gonna do I divided by 0.
And the divided sign?
Yep.
0?
Yep. And go ahead and run this.
Oops. System divide by 0 exception.
Yeah. Go ahead and press continue.
Continue?
Yeah.
Oops. Okay.
Up on top. And then go back to the terminal. So here we got the exception, right? The exception happens to be called divided by 0 exception.
Mm-hmm.
And so this was exceptional behavior. You know, we forced it. We brute forced it. We was like, let's just create an error. But what we can do is we can go ahead and allow your program to continue to execute if you happen to capture those exceptional behaviors, right? So what we want to do is highlight lines 12 and 13. Right click on there. And then down where it says snippet,
Mm-hmm.
we're going to choose surround with. And then type in try. And then tab. Tab. Okay. So the exception that is being thrown is called divided by 0 exception. Okay. But every single exception derives from exception.
Okay.
And so in here, instead of throwing, let's get rid of that throw line, line 20, just Control X, get rid of it.
Okay.
And type in console write line. And then type in, after you see on line 17, after the exception, do a space E to assign that to a variable inside the parenthesis. And then inside the write line, type in e.message. Yep. Play this. Let's see what we get. So now your program continues to flow because you've captured that exceptional behavior and you've dealt with it in such a way that it allows your program to continue. The error is still happening, but you're handling. This is what they call handling exceptions.
Okay.
So that your application just doesn't, go in and barf on you and just stops working. You want to be able to handle these types of exceptions and things like that and have it continue. Now, this is kind of cheating, right? Because one, we're brute forcing it. And two, we're not doing anything about the exception. We're just writing it out to the console. But, this can set you up for when we do a little bit more advanced programming, where we can go ahead and put this code and do something meaningful with that exception and still allow your application to continue working.
Cool.
Go ahead and kill this.
All right.
So that was the exceptional.
Yeah, that was the exceptions.
Cool. Did that make sense?
Yeah, it does. Yeah, I don't